Okay. Welcome back. So, as you might have noticed, I haven't done one of these Advent of Code streams in a while. Uh, it's a run up to Christmas, busy, busy stuff. Um, but I did solve these offline or off camera. So it seemed after we left the port here, we helped some kid with his math puzzles in the air. Oh, wait, that was this one, wasn't it? Oh yeah, this was the memory game thing. Um, so yeah, the ones I've solved on my own or off stream is the Conway cubes. So basically, it's kind of similar to the one we did with the seating puzzle. Again, kind of like the Conway Game of Life thing, only in 3 dimensions, and it's infinite. So I mean, you could cheat this and just make a board that was big enough, but I chose to actually like implement an infinite board for this one. Basically by just having, can have a look at these. That was day 17. So in part 1, basically I create a set of all of the active or the alive tiles. And I create a bounding cube, so where they are, which I initialize here. This is just to print them out in the same fashion that they're printed out here. And then I just loop through, like, for every position in the bounding cube, +1 in every direction. Then count all of the neighbors to that point. And then the 2 rules for whether to kill or make a tile alive. And yeah, then recalculate the bounding box and run that for the 6 loops. Pretty much the same for part 2. Of course, now we have so this was in 4 dimensions, so we added a dimension here. This is now a bounding hypercube, and this lovely thing is, I think, 9 nested for loops, which is not something you see every day. But yeah, the logic is pretty much exactly the same. And day 18, what was this one? 18. Operation order. Yeah, this was the calculator thing. So I've actually implemented calculators before. However, those have been RPN calculators, so reverse Polish notation, which is a lot easier to implement. And it's the kind of calculator I grew up using, so for me they're fine, like to use as well. But yeah, basically this first one was super simple because it didn't have precedence rules. It only had brackets, but that was easily done by just recursion. So when I see a bracket start, we recurse. When we see a bracket end, we just return. And then I just use the string stream so that they're all reading from the same stream, so the position just keeps increasing in the stream. For the second one, so the second one, or part 2, here we have precedence rules. So unlike normal maths, plus is supposed to happen first, and then you time stuff together. I kind of cheated a bit here. So the way you could do this is like make a parse tree and then solve the rules as they are supposed to be solved. But since we only have plus and times and no other operations, I basically just sort of offhanded multiplication. So it reads this, it just does it. Then it sees this and it knows, okay, I need to wait until I find another one of these or the end of the stream, because everything in here should happen before I do this. So it just stores these in like an offhand, and then calculates on, and when it sees the next one, it takes that offhand and times it by the current result, and yeah, it works. It's super simple, but it would be hard to expand to more math operations. But I wasn't in the mood to implement like parse trees and all of that stuff. Anyways, yeah. So our map has updated now. We have flown. So I guess we're still trying to get here, but we had to go a bit of a roundabout because of the storm. I'm a bit disappointed that they didn't like draw a storm in ASCII art. It seems like we have a drawing up here, a little like sea monster thing. I'm not sure when that came. It wasn't there before. But yeah, it seems like we're now going down here to this island. So yeah, the last one was the math puzzle one, and now I guess we've landed. Just before we get going here, I will, bit depending on how long these take, I will probably take a break after part 1 and then come back for or not part 1 and part 2, but for day 19, day 20. So yeah, and also to get them as 2 separate videos on my channel, because this now says day 19. Anyways, day 19, monster messages. You land in an airport surrounded by dense forest. As you walk to your high-speed train, the elves at the Mythical Information Bureau contact you again. So those were the guys who contacted us with the Conway Cube and Hypercube stuff. They think their satellite has collected an image of a sea monster. So that's where that sea monster thing came from. Unfortunately, the connection to the satellite is having problems, and many of the messages sent back from the satellite have been corrupted. They sent you a list of the rules valid messages should obey, and a list of received messages they've collected so far. So that's my puzzle input. The rules for valid messages, the top part of your puzzle input, are numbered and build upon each other. Oh, sorry. For example, 0, 1, 2, 1A, 2, 1, 3, or 3, 1, I guess, and 3B. Some rules, like 3B, simply match a single character, in this case B. So I guess this is like a parsing rule thing. The remaining rules list the sub-rules that must be followed. For example, the rule 0, 1, 2 means that to match rule 0, the text being checked must match rule 1. And the text after the part that matched rule 1 must then match rule 2. So this is pretty much the same stuff you would find in like NPEG. Oh man, it would be so easy to just convert this into NPEG. Some of the rules have multiple lists of sub-rules separated by a pipe. That means at least one. At least one. At least one list of sub-rules must match. Oh, right, to be a valid message. Right. The ones that match might be different each time the rule is encountered. For example, the rule 21331 means that to match rule 2, the text being checked must match rule 1, followed by rule 3. or it must match rule 3 followed by rule 1. Yeah, makes sense. Fortunately, there are no loops in the rules, so the list of possible matches will be finite. Since rule 1 matches A and rule 3 matches B, rule 2 matches either AB or BA, because it's 1-3 or 3-1, so this rule or that rule in the two orders. Therefore, rule 0, which is 1 and 2, so A and then this rule, will match AAB or ABA. Yeah. Here's a more interesting example. 415, so rule 4 is an A, followed by rule 1, followed by rule 5, which is B. So it has to start with an A and end with a B. And in between, we can either have 2-3 or 3-2, and 2 is 4-4, so 2 A's or 2 B's. And rule 3 is an A and a B, or a B and an A. And this one is then either, here, because rule 4 matches A and rule 5 matches B, rule 2 matches two letters that are the same. I'm sorry, I don't have my NIM cup at home. It's at work. I really should be drinking out of that. Here, because, blah, blah, blah. Matches two letters that are the same, and rule 3 matches two letters that are different. Since rule 1 matches rule 2 and 3 once each in either order, it must match two pairs of letters, one pair with matching letters and one pair with different letters. This leaves 8 possibilities: AAAB, AABA, BBAB, BBBA, ABAA, ABBB, BAA, or BABB. Okay, I'm not going to read these. Rule 0, therefore, matches A, rule 4, and then any of the 8 options from rule 1, then B. So basically the same as these, but with an A and a B at the beginning and end. The received messages, the bottom part of your puzzle input, need to be checked against the rules so that you can determine which are valid and which are corrupted. Including the rules and the messages together, this might look like this. Your goal is to determine the number of messages that completely match rule 0. In the above example, ABABBB and ABBBAB match, but BABA, this one, and this one, and this one does not. Do not. Producing the answer 2, because we have 2 of these that match. The whole message must match all of rule 0. There can't be extra unmatched characters in the message. For example, this one might appear to match rule 0 above, but it has an extra unmatched B at the end. How many messages completely match rule 0? Right. Oh wow, so there are actually quite a lot of rules and quite a lot of messages here. Seem to be curiously all be A's and B's. Would have been fun if it had a bit more. Yeah, we're gonna store this. So basically what we're doing is implementing something like a NPEG Lite. Now, I haven't looked into how NPEG is implemented, but I would guess it's pretty tricky stuff. Oops. I was warned that this one would be harder than what we've seen previously. But basically, what we can do, so we have them like 0, 1, 2, 3, 4, 5. So if we sort the rules first, or just add the strings to a table or something, so we can look them up by their number, or do something like that, we can basically create. So these are, we have so few cases. So we have sort of our leaf case, which is just match a character. We have a list of stuff, or we have an option between two lists, right? I'm just going to open up my input here. Okay, so these are actually not even lists. They are just two options, it seems, for all of them. I wonder if there are any. I mean, we can implement them as lists, but that would be an optimization one could do. It actually seems like all of these even are just two, at least in my set of inputs. I mean, this is 3, so we're gonna do those as a list. But let's start with sort of creating a type that can encapsulate a rule. And you will see that nim is actually pretty nice for this. So we're going to make this a reference object and not a normal object, because we are going to be referencing other rules from a rule. So for example, rule 0 here will reference rule 4, 1, and 5. But we don't want to make a copy of them because, I mean, we use these multiple times. So by having them as references, we can store just a reference to the object elsewhere. And we are going to make a rule kind, which is an enum. I'm going to call them leaf, list, and choice. These are just completely arbitrary names. So kind is a rule kind, but we're going to make this a case object. So we're going to say, so rule now has a field called kind, and depending on what the kind is, we're going to have these cases. So the object is just going to have, is actually going to have different pairs of things in it, depending on what kind it is. If you look into the implementation of this, a rule, the size of the rule will always be the size of the biggest branch. So it's implemented, I think, as a union in C. But unlike unions, we actually get some type checking and stuff in them, which is really nice. I mean, it is a single character. Was that defined? Okay, a match a single character. So we can just do character as a character. List as just rules, as a sequence of rule. So here you see we reference this rule object. Choice is going to be what should we call these? Maybe just A and B. A bit wonky, but so those are just going to be 2 sequence of rules. Right. And in the beginning, I imported npeg, and that was to sort of parse this. So we're going to write an npeg parser, I think. Now we want to parse these in a way that we can tie them together easily. So I think we're actually gonna grab a table. Okay, so now we are doing references to a rule. We could technically hold indexes in the table, which will be slower, but we could do that as well. But we're just gonna be using this for parsing. It's a table from int to rule. That is these indices. They won't matter terribly much. So our rule here, these are going to be references to objects, so basically pointers. So these numbers won't exist after we're done parsing, but we do need them to know what we should point to while we're parsing. So let our parser be, I'm just going to pull up the npeg documentation again, and I've pulled it up on another screen. There we go. Yeah. So parser, it's just called peg. Yeah, it's peg, and we are gonna start by reading our input, same as we did before. So we're gonna create a rule called input. So we're gonna be parsing the entire file here. So we should also actually parse rules and parsed. Wait, what were these? These are pictures. Is that what they are? Messages. Sure. Messages. This is just a sequence of strings. So input is going to be a rule, more like one or more rules, followed by a new line, followed by 0 or more messages or message. I say 0 or more. It should maybe be 1 or more. I just could change that. It won't matter to us, but whatever. I'm actually just going to write the message one out real quick because it's going to be super simple. Message matches alpha, so a set of alpha characters followed by a new line. It's gonna have a capture on this, and that's gonna say parsed messages dot add what we captured. Oops, simple enough. Now rule is going to be a bit trickier. So it's going to have a number. So I guess we should do 1 or more, same for this one. 1 or more digits, followed by a colon and a space. So this bit. And then we can have 3 distinct cases. So we're going to say either we have a character, or we have a list, or we have a choice. And we're not gonna, or we are gonna capture this digit. And we are gonna create a variable called current rule. Which is a rule. And when we capture one of these, we are going to say parsed rules at parse int. Our capture is going to be equal to the current rule, and just reset the current rule, basically just making it 0. Oh, and this should not be followed by, this should of course be or. So our character rule is going to be the literal character like that, followed by a single alpha character, followed by one of these. We're going to capture this alpha character, and that should set current rule to be equal to a rule with kind leaf and character equal to our so captures 1.s and the 0, so that's just to pick the single character. This will always match, like this will always be a string, like captures, even though this is a single character. Like so. And then a list. Oh, and this should also be followed by a new line, of course. So a list is going to be digit or digits followed by a space, more digits. So we are going to say digit, one or more digits, followed by a space, 0 or more times, followed by a digit. Oops. Followed by a digit. That should. So you can have 0 or more digits followed by a space, and then end it all with a digit because it doesn't end with a digit and a space. And we are going to capture each of these digits, and we are going to make a rule which has the kind of list, and the rules in this list is going to be captures from 1 all the way to the end dot map it, and it is it dot s dot parse int. So for every capture apart from the 0th, which is always the entire thing, for all the captures, capture or map the variable .s to get the string value out and parse that as an int. So that returns a sequence of ints. That returns a sequence of ints, and this should then be that's an issue. That's an issue because we're now pointing to, or we require that a rule can't reference a rule defined before it. So in here, for example, well, that's not a list, but find a list here. Here. This would read, okay, come to here, read 91, try to look 91 up in the table, but 91 hasn't been parsed yet. So 91 isn't in the table. So this would fail. So I think what we're actually going to do, to mitigate this, I think we are just going to say, we are just going to make these ints. You know what? Let's have a bit of fun here. Let's just say that we have them as index. Just so it's sort of a bit more obvious in our code. So in index, we just defined the index to be an int. And now we can clearly see here that, this index here is obviously an index into this table and not just some arbitrary int. It's just a nice little thing in them that makes code so much easier to read. But yeah, we're going to do that. Map that to an index. I'm not even sure we need to do that since it's not a distinct type. Let's try not to. I'm just curious what happens. No, generic. Oops. We need to actually import tables module. not a fictitious table. Yeah, we haven't made the choice rule yet. Let's just make a nonsensical choice rule real quick. Just something like this. Parsed messages. Undeclared field S. This is capture, not captures, I think. Yep. Compile this. Yeah, that works. So in nim we have, this is just a simple type alias. Like it won't stop me from putting an integer into a field declared as index. This is just a readability thing. What we could do is also have a distinct int. So now this won't compile. If you run this, it will say, oh, I got a table that expected an index and a rule. And I got an integer and a rule. And that's not allowed. You can't have, yeah, you can't, this isn't an index, that's an integer. So you can cast that or convert it to an index, and that's fine. This should also actually complain. Yep. I just nim LSP or nim suggest I didn't pick it up. Got index. Ah, right. Also, since we're adding these into a hash table, we need to implement, like, since we're using it as a key in our hash table, we need to actually parse, or we need to make a hashing function for it, because hashing functions don't exist for distinct types, because it's defined for integers, not for this. We could borrow it from the integer type. There's a special syntax for borrowing procedures from elsewhere, but we're not going to bother with that. We're just doing this for readability purposes. But you can do all sorts of stuff with distinct integers. That's basically if you want to have an integer that follows different rules. So for example, you could have one integer that is kilos and one that is grams, so kilograms and grams. And you can implement addition between them. And you can write the addition so that the result actually makes sense. And the same for like pounds and pounds and grams and feet and meters, and you can do all sorts of stuff like that, which is really quite neat. And I mean, in our case, we could also say like, index. We have a plus operation for index, but that doesn't take normal integers. It takes some, I don't know, index diff integer, which we get from calling some kind of procedure. So I just don't add one to our index and expect that to work if you have a complex data type. Anyways, let's get on with this. So yeah, this should now work because now we are storing the index into the table, as I mentioned when we created this type. This can now actually just be an object because we're only ever going to have one copy and it's going to be in this table. And these are just going to reference indexes into this table. Yeah, so you create the current rule, set that there. Now we need to implement this choice thing. So a choice, it's going to be either or, so it's going to be basically, we can reuse this list. Oh no, we're going to do the same thing I did the last time we were using npeg. So I'm going to create this number list. But that doesn't give me proper captures. This is actually one thing which is annoying with npeg. So in here, I capture digits, and here I capture a digit. All of the digits are, or all of the captures are just going to be in a long list, right? So there's no way of telling. I mean, in this case, I know it's the last one, but let's say we wrote our choice as this, followed by the pipe character, followed by the same rule again. Now, there's no way of telling sort of where this thing occurred. I mean, we could capture it. We could put that also into our list of captures and go looking for it. But there's no way of saying like, give me these things in as a separate thing, and give me these things as another separate thing. And if you put, so now we repeat this 3 times. I kind of want to put that in another subrule, but then I won't be able to get the digits out easily. Luckily for us, this digit rule, or this listing rule, is actually pretty simple. It's just a list of digits separated by the space character. So we can do something like what I'm about to. Just don't capture those, and say that this is just a number list, which with a special capture thing. And actually, oh yeah, we don't actually need a special capture for that. So capture 0.s map over that, just parse int. Dot split. Split splits on white space by default. And we just map parse int over that list. So basically now we don't get the numbers already separated out. We just get them as a list, which is separated by spaces in our case, which isn't the prettiest, but it works. And then we split that list up here. It feels like a hack, but it will at least work. So here we want to capture the number list, and it's followed by space, pipe space, and then another number list. And we need to set the current rule here to be a choice. And the rule, A should be this. So A should be the first capture. This should be the second capture. So this list and this list. 0th capture is again just the whole thing. And that should work. Oh, this should of course be B. Right. And we wrote the messages thing. So I think this should now actually be able to parse our thing. Parser.match. Oh, it had a file thing, right? Input.txt. And let us just echo out parsed rule 0. So the zero rule rules. Oh, and run it. Key not found, 0. And is that from, it's from 39, so it's from here. Which means that this thing never matched. Wait, did our parsing... so our parsing didn't match. We got only to a match length of 10. So we came in here and we stopped on this thing. And that is, of course, because this rule matched that last one. It matched 71 space. So it matched 71 space. And then it couldn't match a digit without a space after it. So number list has to be that. And this has to allow for an extra digit at the end. Or an extra sequence of digits. This will still work because this is the whole thing. And these should now work except for this one. Which is now gonna have to have added on this. So this is to parse the last digit here, because it doesn't have a space after it. Or last integer there. So it's gonna parse the list, which is now just this one, and then this one as that extra plus digit thing. And we expanded the capture to be all of this. Let's see if this works. No, still only got to 10. Why do we only get to 10? So now, what does it try to do? It tries to read this. Then it reads character, or tries to read character. The first one is not this, so that goes back. Then it sees list. And it matches list. So if we reorder this to be like this, I think it should work. No? Is it MPEG debug? No. Oh, that actually output a lot of stuff that I didn't expect. What is MPEG graph is what we want. So it comes into the input and it tries to read a rule. A rule comprises a digit or a loop of digits and this sequence, and it matches that because we're getting further than that. It doesn't match character, so it goes on to try and read a choice, and that reads a number list, which is a digit followed by digits followed by a space, or it's nothing, or it's a digit followed by a space followed by more digits of spaces. Oh, I forgot to remove this space. So when we changed number list to read only the ones with the spaces following them, I of course need to remove that space because it will have been consumed by the number list rule. There we go, that got us further. Invalid integer space, that makes sense. Because now this list right here, when we split that on space, we are getting we can do this as a keep it. It.length is not equal 0. Oops. Is that what it's called? Secutals. Did we? Yeah, we did import that. Keep if. But that takes, oh, it's keep if it. Right. Oops. No. Yeah, keep it if. Oh, keep it if. There we go. Oh, this probably, is this doing something weird with the mapping? Split cannot be assigned to keep it if is not what we want, then is it filter it? But now we want to keep, we want to filter out. Is that how it works? Where is this? Line 33. So what is the filter? Filter, it returns a new sequence with all the items of S that fulfill the predicate pred. Right. So now, we just did the wrong sorts. We just kept all of the ones that were 0. Here we go. Now it matched. And all of these are just noise now. Remove that. And we echo out the parsed rule 0, which is a list of rule 8 and 11. So we can have a look and see if you can find rule 0 here. Yeah, that's 8 and 11. Let's have a look at rule 44, just to double check that that is correct. Rule 44 is a choice between 9171 and 7709. 9171, 7709. That looks good. And let us have a look at rule 77, which is the one that matches just A in our case. And that's a leaf with the character A. Great. Okay. Now that we have our rules, we can loop through. So we should also have all of our messages. Just double check that. I mean, there's a bunch of messages. I am going to assume that it contains all of them. Let's just double check the last one. Yeah, that seems right. So for message in parsed messages. So now we basically need to follow our rules. We want to keep a count of the valid ones. Currently we have 0 valid ones. And we should this is going to be tricky. I think I want to write this as a recursion. So just write this card there for now. I think we want to write this as recursion, and Do we want to have a string stream? I guess we do. So check rule on stream, and the rule is an index into our table of rules. This returns a boolean. Okay, so if our parsed rules rule dot kind, we're actually gonna do this. I'm just gonna rename this rule index there, and we're gonna do a case of rule.kind. If it's a leaf, that's a pretty simple rule to. So if it's a leaf, it's just a single character. So we're gonna do x.readCharacter is equal to rule.character. That returns true if it matches, and it has set our stream to be after the character. No, like even if it's not true. So we're gonna have a list. For our list, we need to revert if it didn't, if the sub rules didn't match. So we're gonna keep our old position, which is the position that our stream is in. Then we are going to, our result is going to be for rule in for sub rule in rule.rules, result equals result, or actually just result is true if x.check rule sub rule result is equal to result and this boolean. But for each rule, oh no, this is in a this is a list, right? So we're just going through the list, checking all the rules, but then we can do early termination. So if the rule doesn't check true, then we set this to false and we break out of our sub rule. If result is false, x.set position to old position. So we save the point where we started checking in the case where we are in a choice. We loop through all the rules. If one of the rules in the sequence that we have to match doesn't match, we return false, and we reset the position back to our old position. Actually, we don't need to do that. We're gonna let choices handle that. So we just read on checks sub rules, having fun. If the result is false, we just break out. We can actually then make this a bit easier and do this. Yeah. So if any of our rules doesn't match, we just return false. Otherwise, we return true. And the stream is just somewhere in the middle, or at the end in this case. If we are a choice, now this is where things gets interesting. So we need to keep our old position. Stream.get position. So we have to do basically this. For subrule in rule set A, if one of them doesn't match, then x dot set position to old position and break out of the loop. And then if old position is not equal to the current position, that means we have run through this and we didn't reset the position and break out of the loop. So that means that we have checked all the rules and they're all true. Then we can just return true. And the position is where it should be. Otherwise, we need to check rule B, or rule set B. If it's not in one of those, we can actually just return false here. And we can return true out here. So this will just leave us somewhere in the middle and return false. But if it matters to us where we are, then we will reset the position here. And that will return us true. So that's a recursive implementation that checks our rules. And before we get too crazy and run this on our entire set, let's try and check this on a simpler set of data. But then we need to do something like this. Yeah, let's actually grab all of these. And let us create, as we have done before, a test input. This is formatted the same way, so it should still be pretty much the exact same thing. Like all of this should just work. Let's do this. And for each of the messages, we need to create a stream. So it's a new string stream of the message. And then if not, check rule stream.checkRule, check rule number 0, or stream or yeah, stream or not stream at end. So if we didn't read the stream all the way to the end, that is also a failure condition. But we should do this if it's true and the stream is at the end, increase the number of valid messages. And for now, just echo out the message. Just do that. So echo out that the message is valid. We have two valid messages, which is what we were expecting out of this set. A, B, A, B, 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 yeah, and A, B, 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 A, B match. So those are the two that we have. The three other ones didn't match. So it looks like we're actually in a good position here. So in theory, we should be able to do this and run this on our actual input. Let's have a look. We don't need this. And just for a little speed up while we're computing, I'm just going to compile this in release mode. 230 apparently match. Hurrah! Okay, nice. That worked really well. Yeah, part 2. Let me do as I usually do, copy part 1 over to a part 2 file. I like to do it this way because then we have sort of a history. We can see what we've done and sort of see how what we implemented with limited knowledge, and then we can see what we implemented once we had further restrictions. Okay, part 2. I'm just gonna check YouTube messages real quick. No, nothing there. Juan Carlos is writing different stuff in the chat. Mostly just emoticons. Oh yeah, we could check rule 34, yeah. I'm not sure if I wanna. It's just gonna be full of 69s or something. Okay, part 2. As you look over the list of messages, you realize your matching rules aren't quite right. Uh-oh. To fix them, completely replace rules 842 and 1142.31 with the following. This small change has a big impact. Now the rules do contain loops, and the list of messages they could hypothetically match is infinite. You'll need to determine how these changes affect which messages are valid. Fortunately, many of the rules are unaffected by this change. It might help to start by looking at which rules always match the same set of values and how those rules, especially rules 42 and 31, are used in the new versions of rules 8 and 11. Remember, you only need to handle the rules you have. Building a solution that could handle any hypothetical combination of rules would be significantly more difficult. Wait, you only need to handle the rules you have? That's not fun. Without updating rules 8 and 11, these rules only match 3 messages. However, after updating rules 8 and 11, a total of 12 messages match. I mean, our system doesn't really care about loops. I mean, it's just indexes in the rules, and this obviously will go on pretty much forever. The only thing we need to sort of check that we're not at the end of the stream. I guess. So it's only in this that we actually do, in this rule that we actually check something. So I guess if x dot at end false, else do this thing. That should handle an infinite rule running to the end. That should be fine. Why is that complaining? Yeah, So this is, I'm not sure why NemSuggest is complaining here, but this is valid in them. So since this case is the last statement in our block here, anything returned by this case statement will be returned. This off statement has an if else statement, and this if branch returns a false, and this else branch returns a boolean. So this off rule returns a boolean, so this case statement returns a boolean, so this thing will return a boolean. It just should work. Anyways, yeah, I think this should match what we have. I mean, I don't see why that should make a difference for us. But we should replace our rules, our two rules, with this. Is this the same for everyone? Or should I make a new input set? I mean, replacing them here would be kind of a pain. Well, actually not. We can't just say parsed rules 8 is equal to rule kind of choice, where A is a sequence of 42 and B is a sequence containing 42 and 8. Good thing I didn't make lists these too long. That would have broken this stuff. Then swap out rule number 42. That's supposed to be oh no, rule number 11. Should also be a choice, this time between 42 and 31. And 42, 11, 31. 31. Oh, whoops. That's not how we create a sequence in them. Do it like this. There we go. I think this should just work. Oh, it still says 230. I kind of doubt that nothing changed. Wait, rule number... Give me rule number 8. 8 is 42, but now it can be either 42 or 42 followed by 8. So that's a loop. Or 11. Where is rule 11? Oh, whoops. 42, 31 can now be 42, 31 or 42, 11, 31. I mean, we did change the rules. And this is all looked up by index. Oh, there. I set these rules and then I parsed all the rules, which reset them. This should do what we want. There we go. That's a different number. That's not the right answer. My answer is too low. Okay. Right. After updating rules 8 and 11, how many messages completely match rule? Okay, so let's try this example set, which is a bit smaller and a bit easier to work with. Or a bit easier to reason about, at least. And this doesn't have the updated rules, so we can just input that here. We're actually going to run part 1 on this as well. Like so. So let's run part 1. That gives us 3. Yeah, it only matches 3. It matches these 3. It should match 12 after we update the rules. So if we now run 2, that only gave me 6. Okay. I wonder if it matches the right 6. And we're just missing 1. So these are the 6 that I match. Let's put them side by side. BBB, yeah, so that matches this one. This one matches this one. That matches this one, and the next one matches this one. That's these two. This one matches this one, and this one matches, I'd say, this one. Right. So we are just missing some. So these are all good, but we are missing some more. So let's focus on this one. Let's just delete the other ones. Well, we don't actually have to delete them from this set. We can just do in here instead of just doing all of them. We can do this, boop, and then say make a stream of this message right there, and then check this rule. We're also just going to echo out this at end thing. Right. We can move this back to here. So it didn't match. Check rule returned 0 or returned false. So we have the rules. Let me just echo out the rule that we're currently checking. Might be interesting. We can sort of see where it goes wrong. And let's do right line. Oh, right. Yep. Let's just return this. Can I do that? No. Can I do this? I can. Okay. But that's not what I wanted. I wanted this, and then I want to echo out the result. And here I want to echo false, echo true. The reason why we don't use result in those is because they wouldn't return sort of early terminates. Well, result is gonna be, oh, how does this write out more than once? Because of this one. No. Echo out result here should be fine because we're just terminating. This also terminates. That terminates. All of these terminate. Where are all these extra trues coming from? I'm just gonna mark these trues with different symbols so I can tell which one is the culprit. It's apparently, oh, we'll have some falses as well. Oh, and they're not all the same. Oh, wait, crap. This should have a new line in front of it, I think. Wait, how can it output more? Ah, right, because this. No, but the lists should output this and their own result. That is weird. Let's just not bother with that. Hopefully we can figure it out without this. Right. Oh, and this should still be an echo then. That might of course have been indicative of of our error, so we might need that to get this going. Yeah, so let's have a look at, let me just open another window here. I'm gonna set the font size up for you guys. We're gonna go into my same folder and we are going to open the test2 input. just open a read-only copy. So, checking rule 0. Rule 0 has a rule 8. So we're checking rule 8. We're going to rule 8. That checks 42. But remember, this is not the actual rule 8. So checking rule 42. Rule 42. Checking rule 9. Rule 9. Checking rule 14. 14 is a B, which is correct because our input starts with a B. I should highlight the... It's this one that we're looking for. Let's just quickly slap that at the end here. So now we have B, which is good. 9, 14, yeah, 14 is B. Then we go to 27. 27, which matches either 1, which is an A, or 6. So yeah, it says 1. Checking rule 1. Oh yeah, and it is an A. Checking rule 6. And rule 6 is 14, 14. So 2 B's after each other. That is correct. So now that means rule 27 has matched this bit, right? And we called rule 27 from rule 14. No. From rule 9. 14 and 27 from rule 9. And we called rule 9 from rule 42. Where's rule 42? 42, 9. That was right above me. Yeah, that was 9 and then 14. So now, oh, Jesus Christ, this is going to take forever. It's got to be something simple we're missing, right? Something easy. Okay. We're doing this a different way. Oops. Oh, we never wanted to change that in the first place. Valid. Otherwise, write out invalid. And let's run this. Still on our test input, remember? Oh, and we should remove that checking rule statement. Right. Is there a common theme? It's not like the long ones. This was annoying. What's the shortest invalid one? This one. Should that be valid? No, of course not. If any of these aren't... So that's matched as valid. And these two are both matched as valid. And this one is the next shortest one. That's the one starting with 5 A's. That one is marked as invalid. This is the shortest one that should be valid but isn't. This test rule set is just too big to be easy enough to read. Okay, before we go any further into this madness, let me just double check that this is correct. Rule number 8, 42 or 42 and 8. Rule number 8, 42, 42 and 8. Rule 11, 42, 31 or 42, 11, 31. Rule 11, 42, 31 or 42, 42, 11, 31. Yeah, okay. I was just double checking that it wasn't something as trivial as that. I don't quite see. Oh, wait. No, this should be here, right? So we added that in. We added this in between part 1 and part 2 because the rules are can now be infinitely long. Oh. Wait, so they terminate? They shouldn't. That should have thrown an exception, I think. Because the rules contains loops. And the list of messages they could hypothetically match is infinite. It might help to start by looking at which rules always match the same set of values. And now those rules, especially rules 42 and 31, are used by the new versions of rules 8 and 11. I mean, this is basically what we were doing with like digits and space and digits. I mean, I guess this is what we are doing. Yeah, we're writing a grammar. I thought that was what we were supposed to be doing. Apparently not. But our solution should work. There's no like technical thing that causes it not to work. But I'm a bit annoyed that this didn't result in an error. So what happens if we say match something to rule 8? Before, so in this test data set, rule 8 is just defined as 42 and rule 11 is just 42, 31. So basically the first part of their choices, right? Right? Yeah, 8, 42, 11, 42, 31. But now they can have sort of loops in them. What does that mean for us? So instead of coming in here and basically rule 8 being a one sub-rule checking rule 42, then quit, it can now be this. So sub-rule in rule A, if it doesn't match the rule, then it resets the position and breaks. Yeah, it breaks out of this so that it can check the other option. I don't think this should cause us any issue. I mean, it would if this rule was a 0 length rule, but then it couldn't never not match. So I think that's fine. For sub rule in rule B, so then it checks 42. Wait, what? Wait. So if 42 doesn't match, right? If 42 never matches, this is never gonna match. Let me try something real quick here. Let's see how this does. 0. Interesting. I would have thought that would be different and not be 0. I mean, that's basically the same as changing. I mean, now I'm changing it for all the rules. Yeah, that makes none of the rules match. Yeah, because we early terminate. Why does it not match any rule? That is so weird. I mean, the I think the problem that we're running into here is that we come in at this rule 42, it matches rule 42, then it breaks out to whatever called rule number 8. And that says something else. So basically this rule 8 is either one 42 or a bunch of 42s, right? There's either a 42 or just a whole list of 42s, rule 42s. So what I'm guessing is happening here is that it comes in, it sees 142, and it says, well, that's good enough for me. And then it breaks. And then it doesn't consume the further 42s, so the next rule fails. So that's why I tried to do this, swap them around. Oops. But that invalidated all of them. And what I was hoping was going to happen here is that it's going to go 42, back to 8, 42, back to 8. Oh, wait. It can, if it doesn't match, then one of the 8s. No, that should work. Why doesn't that work? So we come in. We have a rule 8. So we come into the rule 8. We see we match a 42. We try to match another 8. So now we're into the next number 8. It matches a 42. It tries to go into another 8. It doesn't match a 42. It still doesn't match a 42. It goes back out. So this branch has failed. So it resets to before it found the 42. And then it finds the 42. And it's happy. I don't see why. Because this can't, like, return false. What is, okay, I'm just gonna construct a rule. Just don't run the parser, basically. I'm gonna construct a rule 42, which is a kind of character, or that's just called a leaf. Character is just character A. That's a character literal. So this should now basically match just any amount of A's by my logic. If we match rule 8. So if we match rule 42, just a couple of A's. If we match rule 42, undeclared rule parsed. Oh, parsed rules. Yeah. What? Yeah. It matches. So we're checking now rule 42, which is a single character. So it matches this A character, and then it's done. But the stream isn't at the end. If I have 8, that should now match any number of 42s. Yeah. So now this should have matched 2. Actually, you can give me the position in the stream. Yeah, it's 2 because it matches 1, goes to the next, matches the next one. It fails because it doesn't see another one. It goes back, it matches this one. So now it has matched 2 in total. And it's good. And this doesn't match anything on our rule set, so it fails. If we create a rule 0, that is a rule kind of list where what is that one called? It's just rules. If you say we want to match rule 8 followed by an imaginary rule 2 followed by another 8. We're just going to make a rule 2, which is a B. So this should be true, 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 false. 2. Interesting. Wait, so is that my... If I do this, and I just check this, and I don't create any more of my silly rules, oh, and I don't like that this doesn't work. Yeah, that's still 6. Why did that happen? Ay. Rule 8. Rule 42. Rule 42 is a check because it's an A. Then it carries on and tries to read another rule 8, which reads a 42, which is a check. Then it tries to read another rule 8, which is a fail. Failed both here and here. It falls back. This failed, so it tries to read this, which is a 42. This is a 42. That's okay. Oh, we check rule 8 here. We should check rule 0. Yeah, that's what I expected to happen. This was harder. I mean, we are apparently doing the sort of the hard version, according to this. You only need to handle the rules you have. So we could theoretically just write these rules as a npeg parser and be done with it. And just let npeg handle it. But this annoys me. I'm gonna do result. False, 4. What? Oh, because this that sets the stream to a weird position. False 1. Oh, Basically there, what I did there was sort of change the rule for precedence, or for this should now also work. No. God damn it. But that, I did change something there, and I wonder. Zero. Great. Wait, but it didn't output anything. What the hell? Wait, what? It should have at least listed them out. Oh, we didn't parse our... I forgot that we removed the rules parsing thing. Yeah, still invalid. Basically what I said here was that like if we have a good result already, like if instead of just early returning, we try the other branch as well. And if all of that match, then we return that. And if not, then we try. So basically I changed, well, I guess I just changed the precedence like we did before. I guess if I do something like if good position is smaller than so match the shortest of the two. Don't do that in release mode, so I can see the actual error. Oh, wait, what? That went too deep. Interesting. That did actually get us a good looping. I'm guessing it's because it just keeps setting the position to the same one. But none of the rules should have a 0 length. So why does it do that? Right. Yep. Yeah, same thing. I'll just try this as well. Yeah. It shouldn't be greedy. It should be like conservative, not take too much from the stream, which is basically what this is doing. So this chooses the option that takes the fewest amount of elements from the stream. But that still doesn't help us. Apparently. This was annoying. Did it have a like actual run through example? No. So we'd have to run through this and manually check all of these rules, which is just going to take a lot of time to find our issue. It still annoys me that sort of this doesn't work. I guess now it works. No. That's even weirder. Anyways, I think we'll let part 2 there lie, for now at least. I'll basically just restart the stream, so that I can update the video title on YouTube. So I'll be back in a second, and we'll have a look at today's puzzle instead, because this was yesterday. So for those of you watching on YouTube, there will be a new stream. I guess for Twitch, it will just be the same one. So yeah. Okay, back in